Welcome back, llamas. This is block 1 from topic 11, designing experiments. This whole topic we're going to be looking and designing experiments, and we have to design them appropriately. So we need to look at the criteria that is required. We are on page 351. First, what do you think the probability of a baby being born a girl is? 50-50, because theoretically, is that theoretically or experimentally?
Theoretically.
Why theoretically?
Well, it wouldn't be experimental because you can't experiment on, it's called
2020, but it is theoretically that it is 50-50 boy to girl. But think of your own family bloodline. Okay, so if my dad had a brother and married his wife, is that his wife my bloodline? No, we're not blood relatives. She has no play in the kid I would produce. So think of your bloodline. Would your experimental probability be 50-50? Higher girl, higher boy? I'm going to take a poll, so put your hands down. Put your hands down. Looking at bloodline. So, raise your hand if you think, based on your family bloodline, your chances would be 50-50 either way. Mine is 50-50, about equal, boys to girls.
Well, before me, I think there's more,
You're looking bloodline, not just your brothers and sisters. You're looking your aunts and uncles, grandma and grandpas, all of that. Mine's about 50-50. If your cousins are blood.
Mine's about like 7.
Raise your hand if you feel your family is more boys. Okay. Raise your hand if you feel it's more girl-sided. Okay, put your hands down. All right. Well, technically, us girls should not have even participated in that poll. There is one major factor of why we should not have participated in that poll. Raise your hand if you know why girls should not be able to participate in that knowledge. Caleb, what?
Well, because the male, he determines the gender.
Exactly. Males determine the gender of the baby. So does all us females in here know the father of our kid? Nope, I hope not. Okay? So we don't know. We have to look at the father's bloodline. The mother's bloodline has no play in it whatsoever. So anything that the girls raised their hand for, all we can go on is theoretically right now because we don't know the experiment of who the father would be at this time. Okay? But boys, you could already predict whether it would be higher chance boy, higher chance girl, or 50-50. You already know that. Okay? So there's a little cool information that I have access to right here. This is the current enrollment at our school. 6th grade, 7th grade, and 8th grade. Blue is male, red is female. So looking at 7th grade. Shh. Not funny. So, yeah, you did.
He's going to jail.
female, we have 151 females currently enrolled in 7th grade. Males currently enrolled today. Actually, someone must have just enrolled because this number changed from earlier today. 168 males. So, this year that kids were born for 7th graders, was it higher probably for a boy to be born or a girl to be born? A boy, very slightly higher, not a whole lot. So, that's kind of neat to look at. So, the problem we're looking at today is we have this delivery nurse, and she's in charge of ordering the pink and blue blankets that the babies get wrapped in after they're born. And she went on theoretical probability. So she bought half pink blankets and half blue blankets. And she found that she was running out of pink blankets way faster than blue blankets. Okay, that's this particular year and this particular hospital. Okay, just both of you stop. How about that? So yeah. She wanted to conduct an experiment, but she didn't. So she experimented for 100 days and kept track of boys and girls that were born. And she got this information that is in your book. Okay, so she wants to know the percent. So let's take a look and find the percent of boys that were born. So how many total boys were born? 150. Out of how many total kids? 350. I'm finding a percent, and percents are over 100. So if you recall, we multiply and divide. Some of you have calculators in front of you. Help me out. What? Anything?
15,000.
42.8.
Yes. 15,000% is going to be born boys. Yes, absolutely.
42.8571428. Rounding.
You didn't divide by
8 what?
8571428.
So I want to. I want to round this to the nearest whole number, so that would be what percent? 43%. Okay, let's calculate girls. How many girls were born? 200 out of how many total? 350. Percents are over 100. So I multiply, divide, and I get 57.11 what?
57.14.
4. What whole number does that round to? 57%. What should both of these percents add up to? 100. Okay. If they did not add up to 100, that means I rounded incorrectly. And your rounding was off. Alright, so moving on. We need to define a simulation because we're going to be simulating things this unit. Raise your hand if you feel like you've been in some type of simulation. or simulator before?
Like laser tag?
No.
Raise your hand if you think. If you don't know, then don't put your hand up. Okay? You can put your hands down. Everyone's hands probably should have been up if you've ever played a video game, because a video game is a simulation. You're simulating something happening. There are simulations of at NASA where you're simulating going to space. Did you really go to space?
No.
No, you simulated it. There's simulations at Disney World. Several rides are simulating you going through a jungle or
like
You
going
in
through
space.
hyperspace. Or like the
In
T-Rex
Or
one.
like the
Or- the Avatar ones. Okay? VRs
Star Wars one?
are simulators. Are you actually at those places? No.
But they're just saying questions.
Altitude has a simulator. What does altitude have a simulator of?
A hurricane.
A hurricane. Are you actually in a hurricane? No. iFly is a simulator. What are you simulating?
You're flying.
Flying.
That you're flying. Okay, so a simulation is a model of a situation that can be used to explore how things might happen in real life.
Like, you know that simulator thing in the mall?
I ain't been to the mall in a while, so I don't know. Is it VR?
Yeah, it's like VR.
I've seen people do it before. I didn't want to do it because it wasn't like all. It's really.
No, it's actually pretty cool. They have golf simulators, but you don't actually have a I don't know what altitude you jump.
Or like I can see other songs whenever you go to Walmart, whenever you do the grab thingy. You never get anything. I get something.
Okay.
Of course you do. Done.
So what are some examples of simulations? We just listed a ton. These are the ones I'm going to write. A flight simulator. Pilots don't first learn how to drive by flying a real plane. They have a fake plane that simulates it. Simulation of driving a car. They don't do crash tests when the first crash happens. They test the car before it is sold. Video game simulators.
Like World War II.
Mm-hmm. VR, isn't it?
Oh, drunk lizard flying.
Oh, yeah. They're simulating. Quiet. I don't want to tell you 5 times. Obviously not in the mood. You're just trying today. I had a thought. Oh. What are some math tools that you have used for probability so far? A spinner?
Yes.
A spinner? What else?
A graph?
A coin.
A coin?
A dice?
A dice?
Clock?
A
watch?
Rolling
I
like.
haven't used goggles. Oh, marbles. So these are mathematical products I can use to help simulate situations. So spinners, dice, and coins. They can give us data.
Like, what kind of spoon is that? Like a ball.
Okay, there are 5 steps to conduct a simulation properly. So 5 steps are fitting in this area, so make it work. Step 1 is identify a model. This is the theoretical probability of the event. Yes, you're writing the highlighted blue words as well. Identify a model, the theoretical probability of the event. So identifying the model, if I was talking about that nurse with running out of blankets, my theoretical probability was what for the nurse? 50-50. Because boy and girl theoretically should be 50-50. That was step 1. Step 2, define a trial. This is the event or series of events that model the situation. So defining a trial. She wants to simulate whether it's going to be a boy or a girl. And she wants to do that in a matter of a couple minutes. Is that many babies going to be born at her hospital in a couple of minutes? No. So she wants to use some mathematical tool that has the same number of sections as the number of topics she's looking at. She's looking at boy and girl. How many things is she looking at? 2. So what mathematical device do I have that should work that has 2 sections?
A coin.
A coin. Thanks for shouting out. So, a coin, we could make one side represent a girl and one side represent a boy, and she could flip the coin. Third step is record the statistics of interest, the data you are interested in studying. Is she interested in the color of hair of these kids?
No.
Is she interested in the eye color?
No.
No, she's interested in whether it's just a boy or a girl. So that is the data she's interested in. Step 4, repeat the trial. You're going to decide how many trials will give you a sufficient amount of data. If I just flipped a coin 5 times, is that going to be enough times to give me sufficient amount of data? No. Is it experiment ever sufficient with a low number? No. The more times you do an experiment, the better the results. So you're going to repeat the trial. I have number 4 up and you're not writing. And lastly, there's no possible way y'all had 4 written down.
I don't think he did the highlighted things.
I thought all we had
She
to write
didn't
was-
highlight it.
I need the whole thing.
Oh, I thought you said
Good
only
thing
the
I did.
highlight. Wait, so we were supposed to write the stuff that's not highlighted?
This one you're writing all the blue for number 4.
Oh,
This I shortened it with the highlights. And step 5 is to find the average or the mean. That's where you divide the number of times the event occurred by the total number of trials. Okay. Now we're gonna set up for an a simulation. So number 6, 7, and 8. I have this computer game, but I don't really have it in my possession. I need to simulate it. And it has these 4 different rooms. And you have to find the key in order to unlock to go to the next level. So you need the probabilities of where the key might be. So I have 4 rooms. Are all the rooms the same size?
Yeah, no.
No. What is the largest? Gallery is the largest, and really, how many rooms could fit in the gallery?
3.
3. So I'm gonna go like this, and it kind of looks like I have how many rooms? 6. But 3 of them go to what room?
8.
The gallery. But I wanted to divide them up because it's larger groups. So this whole thing represents 3 rooms. I have 6 items. What math tool could I use that has 6 sections? A number cube. So that's what I'm going to use. I'm going to write that for number 6. Okay, I need to define what I want to call when I land on a side 1. What section do I want to represent a 1? Okay, yours does not have to look like mine, but I'm calling that a 1. So if it lands on 1, that's going to be the dining room. What do you want to be 2?
The library.
I'll go 2 there. What about 3?
Gallery.
Okay, we'll change it up. 4 where?
Bottom right.
Bottom right.
Okay,
That's tough.
I'll put 5 here and 6 there.
Why do you not just put 3 on?
Did it matter where I labeled this? No. So that means if I roll this dice and it lands on a 5, what room is the key in? The gallery. If I roll it and I land on a 3, what room is the key in? The gallery. It has more chances to be in what room? The gallery. So I want you to draw a table like this for number 7. You could use D, L, T, and G instead of writing out all the words. So number 7, sketch you a little table that looks like mine.
Bro, you nasty. I need to you straight nasty.
Okay, you can go ahead for number 8 and sketch this table as well. If you don't sketch my example, you could use the letters. Ethan's.
We do DLTG.
Alright, so I'm gonna simulate. We're not gonna have time to do this today. This is gonna be one thing you do tomorrow. So I have to roll this dice how many times?
6. As much as you want.
50 times. 50.
It says 50 trials. Circle that. So I would have to roll this 50 times. I landed on a 1, so that represents dining room. I'd put a tally. You're not putting a tally. I'm just pretending. I would roll it. I landed on a 4. That represents throne, so I would put a tally. Roll again. I got a 6. That's gallery. Okay? I'm going to do that until I've rolled 50 times. Let me finish. Thanks for interrupting. I'm going to roll it 50 times. Then I'm going to have a number for each of these. For instance, I might end up with 8 for the dining room. So then I would go to this chart, write 8 times, and then calculate my mean. My mean is 8 divided by 50. Where'd they get 50 from? Number of trials, and I got 0.16. That's the mean. No, it's my example. Okay? Then I would look at the library, see how many total times it landed on the library. Is anybody's probably going to look the same? No. Just you and your partners. Your partner sitting next to you. Okay? That's going to be tomorrow. So there's no homework tonight.
Yes.
Thanks for listening. Like, subscribe, hit the notification bell, and peace out, llamas.